Welcome back. Now you know what polar form is. There are rules that govern how you can multiply and divide complex numbers that are in the polar form. This is one of my favorite proofs. I make my students do it every year, and today I'm going to take you guys along for the ride. So we're going to start by having two numbers that are both in polar form. So they're going to have a different modulus and a different argument. Okay, so we're going to multiply them and see what happens. So first of all, I'm going to take the R1 and the R2 out to the front, and then we're going to be multiplying cos alpha plus I sine, I was going to write theta there, but I sine alpha, and then we're going to multiply cos beta add I sine beta. I'm actually going to do this in a grid because I think they'll be a little bit easier for you guys. So you could expand it like this though, just as easily. So imagine we've got cos alpha, positive I sine alpha here, and over here cos beta, and here I sine beta. So the first one we'd have would be cos alpha cos beta. Then we'd have I times by sine alpha cos beta, and here we'd have I times by sine beta cos alpha. Now here we'd have I squared, which would be minus 1. Don't forget, I is the square root of -1, so the square root of -1 squared is going to be -1, and that's going to be sine alpha sine beta. Now, before I write this neatly, I'm going to give you a tip. Whenever you're dealing with complex numbers, you always want to reorganize into your reals together plus your imaginaries together. So in this case here, my reals are the part that do not have an I, and my imaginaries are the parts that do have an I. So I'm going to remember that R1, R2, I'm going to write this a little bit in abbreviated form. So we know that R1 kiss alpha times R2 kiss beta is equal to cos alpha cos beta minus sine alpha sine beta. That's your real parts. Okay. Plus your imaginary parts. It's going to be sine alpha cos beta add sine beta cos alpha. Now, you might want to pause the video for a second and have a little look at these trig expressions and see if they look familiar to you. So I'll give you a little second to think about that. Did you remember? This is actually the compound angle formula for cos alpha plus beta, and this one is the compound angle formula for sine alpha plus beta. Now I seem to have forgotten my R1 and R2, so I'm going to put those back in there. Remember, this was the R1 and the R2 were on the outside, so it's, squeeze them in here, R1, R2, and here R1 times R2. So to summarize what we've learned that if I have to do R1 kiss alpha times by R2 kiss beta, there's actually a shortcut. You just need to multiply the moduluses together, and you just need to add the angles. We can write that in long form like this. Now, if you hang around for the next video, I'll show you some practical examples of this rule with numbers. So I'll see you then.